This is section 12.7, the law of sines. How do we use the law of sines to find sides and angles of triangles? So in section 12.6 we used the law of cosines, and to use it we needed either the lengths of two sides plus an angle, or we needed the lengths of all three sides. So if you recall, these were the three formulas we used. In all of these cases we either needed two of the three sides plus an angle, or you needed all three sides, and then you can solve the included angle to the side on this side over here. Now with the law of sines, even if the angle you have is not the included angle, you can use the law of sines to solve triangles. So let's first take a look at what the law of sines is. It's pretty simple. In any triangle ABC, the sine of A over A is equal to the sine of B over B is equal to the sine of C over C. If you want to see a proof, you can find one in the book, but I'm not going to spend time doing it here. Suffice to say that basically the sine of an angle over its opposite side, the ratio is equal no matter which angle and which side you pick. So sine of angle A over A is equal to the sine of angle B over B, and this is equal to the sine of angle C over C. Example 1. In triangle ABC, we're given angle B is equal to 52 degrees, side A is 3, and side B is 4. We're going to try to find angle A. So all we have to do is use the law of sines. So since the law of sines is a ratio of the sine over each opposite side, and they're all equal, we know that the sine of angle A over A is equal to the sine of angle B over B. We don't have to worry about sine C over C because we're not worried about C. We don't care in this problem. So at this point, all you have to do is plug and chug. Plug in 3 for A, little a, 52 for angle B, and 4 for side B. And this just solve for A. So we know that the sine of A, by doing some algebra, is 3 sine 52 over 4. Therefore, A is the inverse sine of 3 sine 52 over 4. I can tell you this is about 0.591. Of course, I did that in my head. So A is either equal to 36.2 degrees or 143.8 degrees. Notice that you can have two different angles for the inverse sine because sine is both positive in the first and second quadrant. So you're almost always going to have two possible angles for A when you do the inverse sine. Now, how do you know which one to use? Well, you know that angle B is 52. So if you use the 143.8 degree angle, you're going to exceed 180 degrees as the sum of those two angles. So, therefore, angle A has to equal 36.2 degrees. But again, a very important point. A can be one of two angles here. Some answers will allow you to have both. Let's say B were a smaller number and A were a smaller number, and both of those numbers plus B were equal to or less than 180, you could use either answer for A. So you'll see some of those problems on your homework, but check the answers. In this case, if you use 143.8, that's not going to be a plausible triangle because you already have an angle that's 52. That's going to be well over 180 when you add them together. So again, the law of sines, a lot of plugging and chugging, but watch out for this little wrinkle, because the inverse sine of A, or the inverse sine, could yield you two possible answers. Example 2. We're now told that side A is 52, angle A is 74 degrees, and angle C is 38 degrees. Go ahead and find side C. Try this one yourself. It's not that difficult. And let me know when you get the right answer. Well, to start the video when you get it. Alright, in this case, you just have to use sine of angle A over A is equal to the sine of angle C over C. So plug and chug again. Sine of 74, which is angle A, over 52 is equal to the sine of 38 over side C. So C is equal to 52 sine 38 over sine 74, which comes out to be about 33.3. So when you're looking for a side, you don't have to worry about two possible answers. You just plug in all the numbers, do some algebra, and whatever you have left here is going to be your missing side. Example 3. We're given that side C is 73, angle A is 27 degrees, and angle B is 34 degrees. Find side A. Now, you'll have to do some math here. See if you can figure out the way to do this problem, and then pause the video, check your answer when you're ready. Alright, first thing you want to know is what is angle C? Well, you can do that because you have angles A and B, and you know that all three angles of a triangle have to total 180. So C has to be whatever's left. 180 minus 27 minus 34. So C is 119 degrees. Well, at this point you have angle A, you have angle C and side C. You now have enough information to solve for side A. And you use this part of the law of sines. Sine A over A equals sine C over C. And then you plug in the values. Sine of 27 over side A is equal to sine of 119 over 73. And solve for A. A is equal to 73 sine 27 or sine 119. So A is about 37.9 units. So if you're looking for a missing side and you have two of the three angles, you can always figure out the third angle by recalling that the angles of a triangle total up to 180. Example 4. Find the exact value of A over B in triangle ABC if sine of A is a half and cosine B is 3/4. Now how would you approach this problem? Well, we can use the law of sines. We know that sine of angle A over A is equal to sine of angle B over B. So we want to know what A over B is. Well, we can rewrite this by doing some algebra, and A over B is going to be equal to sine of angle A over sine of angle B. Well, that's great. We know the sine of angle A. Now we just need to figure out what sine of B is. And this is what helps if you remember the main trigonometric identity of sine squared B plus cosine squared B equals 1. So you plug in sine squared B. Well, you're looking for sine squared B. You know cosine B is, so 3/4 squared equals 1. So sine squared B is 7/16, and so the sine of B is equal to radical 7 over 4. Now, you're wondering, well, is it positive or negative? Well, keep in mind in a triangle, the sine of any angle between 0 and 180 is always going to be positive. So you're never going to have a negative value for sine here because you're dealing with a triangle. So, in this case, sine of B is positive. So now, when you calculate A over B, you just plug in what you have for sine A divided by sine B. So it's 1/2 divided by 7 radical 4, which simplifies into 2 over root 7. Since you cannot have radicals in the denominator, you multiply the top and bottom by root 7, and your final answer is A over B is equal to 2 radical 7 over 7. So again, in this case, you just use the law of sines and you rewrite the law of sines, rearrange the terms so that you get this A over B ratio that you want. To find sine A, you have it. To find sine B, you need to use this identity because you are given cosine of B. Plug that in and you get the sine squared of B equals 1 minus 9/16 or 7/16. Take the square root of both sides and you get sine of B is radical 7 over 4. Plug that in over here and then solve for A over B. Last question, number 5. The captain of a ship sighted a reef located so the angle between the line of sight to the reef and the ship's course was 20 degrees. After sailing 8 kilometers, this angle was observed to be 70 degrees. At that point, how far was the ship from the reef to the nearest tenth of a kilometer? Alright, go ahead and try this one yourself. I'm going to guess most of you are going to have problems drawing the picture, but you can surprise me. Alright, let's take a look at the picture first. Nice white canvas. There's a boat. The boat is going from left to right on your screen. The boat guy, the boat captain, spots a reef, and the angle between the line of sight to the reef and the ship's course was 20 degrees. So you draw a line from the boat to the reef, and this is a 20-degree angle. Alright, let's see if you can get the rest of the picture if you haven't already. Now, he's moved 8 kilometers. And now, he looks at the reef again at this point here, and he notices this angle is now 70 degrees. Now, you have a triangle. How far was the ship from the reef at this point? So you're going to look for x. How do you solve for x? Now that you have a picture, see if you can use the law of sines to figure out what x is. You might have to figure out what this angle is there first. Alright, let's plug in some values. If this is 70, we know this angle inside the triangle has to be 110 degrees because they're supplementary. If this angle is 110, we know that this angle next to the reef has to be 180 minus 20 minus 110 or 50 degrees. So, we can use the law of sines. The sine of 50 degrees over its opposite side 8 is equal to the sine of 20 degrees over its opposite side, x. Now that you have an equation, solving for x is very easy. X is equal to 8 sine 20 over sine 50, which means x is 3.6 kilometers away. So the law of sines is pretty useful because you are no longer restricted by which angle you know. Now, as long as you have one side and one opposite angle, you can figure out the ratio between the sine of an angle and over its opposite side. And you can use that to solve for almost any side or any angle of any triangle. Alright, that's it for example 5 and for section 12.7. Again, look over example 1 and understand that you can get two different angles when you do the inverse sine of an angle. If you have any questions, ask me in class or post a question over email or on the Facebook group.